Alright guys, so what we're going to be going over is the review. So we're going to start with the easy part. Get that better adjusted so that we can see both the things that we need to look at. Alright, so as I said up here, there's 6 types of angles. 4 that we've talked about in this chapter and 2 that we've talked about before. They're corresponding. Alright, remember corresponding means same position. Okay, so like 9 and 13 are in the same position in their groups. Then you have vertical, which means diagonal from. Alright, but they're only diagonal from when they're in their own groups. So like 3 and 6, yes, they're diagonal from each other, but they're not in the same group. So like 3 and 2 would be vertical angles. Then you've got alternate exterior, means diagonal from on the outside or on alternate sides. Then you have same side interior, where they're on the same side on the inside. And then you've got adjacent. Adjacent means next to, like 3 and 4. Okay? So, we're going to start with 1 and 4. So 1 and 4. 1 and 4 are diagonal from each other. They're in the same group. So we know these are vertical angles. So these are vertical angles. Alright. Next thing is 12 and 13. Now, when I have these problems, what I like to do is I like to cover up the one line that I am not using. Now I'm using this line here, using this line here, and I'm using the transversal right here. So the only line I'm not using is AB. So what I'm going to do is I'm going to cover up AB, and it's left with this. Now it's a lot easier to tell what 12 and 13 is when you take away one of the lines rather than having the whole thing like that. So we're going to look at 12 and 13. So you got 12 here, 13 here. Now they're both on the inside. They're in between two lines, so we know there's some type of interior. And they're diagonal from each other, so we know that they both have to be alternate, alright, meaning diagonal from each other, interior. So these are alternate interior. Okay, so I'm going to do that little trick again, but 7 and 14, so let's cover up the line we're not using, which is that one right here. 7 and 14, alright. Now if I didn't lose that line, then it would kind of look like 14's in between something, but if I cover that up, you can notice that now it looks like they're both on the outside. So we look at 7, we look at 14. 7 and 14 are alternate, okay, so meaning they're on the different side of the line, and they're on the outside, meaning exterior. So these are alternate exterior. Alright, next, 2 and 9. 2 and 9, right up there. They are inside. Alright, so they're inside the lines. Right here. They're on the same side. So they're in between these two lines, and they're on the same side of this one line. So that means they are same side interior. Okay. Next one, 6 and 15. So we know 6 is here, we know 15's here, so we need to cover up this line. They're both on the inside, diagonal from each other. So once again, alternate interior. Alright, next one. Okay. 5 and what angle are corresponding angles? Now, I can't really cover up a line here, so we're just going to circle 5. Alright, what I'm trying to look for is an angle that is in the same place as 5. Okay, so if you notice right here, 1 is in the same place as 5, and so is 13. You could have chosen 1 or 13. Now, 9 is not possible because of this. If I cover up this line just showing this, you see 5 and 13 works. Cover up this line, you see that 5 and 1 works. But if I cover up the line that 5's on, you don't see it anymore, so 9 wouldn't work with that. So it's not technically a corresponding angle necessarily. All right, so I'm going to call this angle 1 or angle 13. Okay. All right, this next couple are just going to be, we're going to come back to the graph, but first let's look at the question. It says angle 6 and what angle are alternate interiors? So 6. All right, so 6 is right here, so I'm going to erase this rest of the stuff. 6 is right here. All right, so we got to figure out what is a angle that is diagonal from 6, and that's in between two lines. Now, if I look in between these two lines, okay, in between these two lines, you see that 6 and 15 are both on the inside from each other. They're diagonal, and they're in between these two lines. So we could say angle 15 for this one. Okay. The other one we can look at, okay, is 6 and 3. If you notice 6 and 3, it's in between these two lines now. And 6 and 3 we can connect like this. Okay, so either 6 and 15 or 6 and 3. So we're just going to put or angle 3 right there. Last but not least is angle 14. Our blank and angle 14 are adjacent angles. I'm looking for the angle right next to 14. So that means that it's either this one or it's this one. So we could either say 13 or 16 because these are the only two that are right next to it. Okay. All right, to the next one. All right, so now what we're going to do is we're going to try to see if we can find parallel and skewed lines. Now, remember, parallel lines means that it's the line, all right, the lines are going in the same direction, like these two, and they do not touch ever. Now, skewed means that they're never going to touch, like this one and this one over here. These two will never touch. But the fact of the matter is that this and this are not going in the same direction. Though they will never touch, they also are not going in the same direction. So, first things first, is we're going to try to find all the lines parallel to NJ. So we're going to look for NJ. NJ is right here. We're going to look for all the other lines that look like NJ, meaning they're like slanted a little bit like this. So we've got OK, we've got QM, and we've got PL. Okay? So all four of these lines are parallel to each other because they're going in the same direction. Okay? And they'll never touch. So we'll say OK. We'll say QM. And we'll say PL. Next one, ML. Alright, ML. ML is right here. So we're looking for all the lines that are going up and down like ML, which is like QP, which is like JK, and which is like NO. All four of these lines are going up and down. They'll never touch, and they're going in the same direction. They'll never touch, so on and so forth. So we'll say NO. We'll say QP, and then we'll say JK. So that's what it means to be parallel. They have to be going in the same direction, and they must never touch. Okay. Now, skewed. Find a line that is skewed to OK. All right, so OK is right here. That's where OK is. Now, we're going to try to find a line that does not go through OK, but does not go in the same direction as OK. So, things like JK is going through it, so that wouldn't work. Neither would NO. And things like PL or QM are going in the same, look the same, so that means that they can't work. So things like this, like if we had JM, if you'll notice, JM and OK will never touch. They'll never touch, but they're not going in the same direction. So something like JM will work, or NQ will work, or QP will work. Any of these will work as long as the line will never touch this and is going in a different direction. That's what skewed means. Find a line that is parallel to Q and QP. So once again, what's different about lines being parallel to each other and plane and a line being parallel to each other is that a plane, two lines, they have to be going in the same direction and they must never meet. In this case, the plane and the line must be just never meet. So we have QMP, which is this little plane right here. Now we need to find a line that does not go through it, like JM goes through this, or NQ goes through the plane. We need to find one that doesn't go through it. So something like NQ, JN, stuff like that will work because these are going parallel to it and never touch the actual plane over here. So we can say something like NJ. Alright, last but not least, it's asking KL and are the lines KL and NJ parallel? Explain why or why not. So KL is right here, NJ is right here. Now, we can say these are not parallel. The reason why is they're not going in the same direction. Okay, so that's why we call them not parallel. All right. Now, the better term to say that, even though they're not touching, is to say that no, they're not parallel because they are skewed, meaning they'll never touch, but they don't go in the same direction. No, they are skewed. Alright, next one. If angle 1 is, okay, so now we're going to go back to our 6 different things: vertical, corresponding, alternate interior, alternate exterior, same side interior, and adjacent angles. Alright, first things first, 1 and 5. 1 and 5. 1 and 5 are corresponding angles. Now, angles, these angles with parallel lines are going to either do one of two things. They're either going to be the same, meaning they're congruent, or they're going to add up to 180. Okay? In this case, 1 and 5, we know that corresponding angles are congruent, meaning they are equal to each other, or at least their measurement is equal to each other, I should say. So you have 1 and 5 here. So if we know 1 is 72 and 5 is congruent to that, that means that 5 also has to measure 72 degrees. The next one says if angle 6 is 87, what angle 7 be? So 6 is here, 7. So these are across from each other, what we call vertical angles. Vertical angles are special angles that are right across from each other that are formed by two lines crossing. We know that these are also congruent from previous chapters. So we're going to say that since angle 6 is 87 and angle 7 is congruent to 6, we can say that angle 7 is 87 degrees. The next one, angle 2. You have angle 2 here, you have angle 7 here. What these are alternate exterior. Alright, so your alternate interior, alternate exterior, your vertical and your corresponding angles are all congruent. So 2 and 7 is also congruent because they're alternate exterior angles. So what we can say about angle 2 and angle 7 is they're congruent, so we know that angle 7 has to be 35 degrees. Now here comes a little bit more tricky part, is actually throwing in a variable. So we know angle 3. So angle 3 is right here, and then angle 6 is right here. So just like we said with alternate exterior, alternate interior, which is 3 and 6, are also congruent, meaning they equal the same thing. So if we know 3 is 77, we know that 6 also has to be 77. But since 6 also equals 7x, we set these two things equal to each other to solve for x. Okay? So this is divided by 7, you should get x equals 11. The next one's a little bit tougher. We got 5 and 3. 5 and 3 are same side interior. Now, you remember I said they're either going to be congruent or add up to 180? 3 and 5 are supplementary, meaning they add up to 180. So this is how we're going to change this up a little bit. We know that angle 5 is 132. We know that whatever this angle is, if we add it to 132, they should both add up to 180 degrees. So we can set up our equation like that. Here's angle 5. Okay, so we have angle 5 plus angle 3 equals 180. And since angle 5 is 132, angle 3 is 4x plus 2, we can just replace or substitute those things in. Now that we have 130, we can combine like terms. So we'll get 134 when we combine 132 and 2, plus 4x equals 180. Subtract 134, subtract 134. You should get 4x equals 46. Once you do, you can just divide by 4. Both sides, x should give you 11.5. Alright, last one. Angle 7 is 45 degrees and angle 2 is 15. What would x equal? Alright, so what would x equal? Alright, so we know that 7 and 2. Well, you should know from this previous question, 7 and 2 are alternate exterior angles, meaning this 7 and this 2 right here are alternate exterior angles. What we know about those is that they're congruent. So what we can say is that if 7x equals 45, angle 2 equals 15x, we can say that angle 7 is congruent to angle 2, which means that 45 equals 15x. Divide by 15 on both sides, divide by 15 on both sides, x equals 3. Alright. This next one. Okay. So, this is how we solve these. My class, and if you're watching this from another class, I taught it a little bit differently. There's a theorem. Alright, this theorem states that any exterior angle on a triangle should equal the two angles not touching that angle. Okay, so that means that 118 should equal x plus plus 35. Now, what I taught my kids is a little bit different. So I'm going to show you my way, and then I'll show you what my students, or what the other way is, or the way you might have been taught. So, first things first, you have y right here. We know that these two angles have to add up to 180 degrees. So to find y, we can say that 118 plus y equals 180. Okay, then we can get rid of 118 to get y by itself. We get y equals 62 degrees. Okay, so we have y equals 62 degrees. So we can say that this is 62 degrees. Now what I tell my kids is that all triangles add up to 180 degrees. So since all triangles add up to 180 degrees, what we do is we take 62 plus 35 plus x and set it equal to 180. Combine these two together, you get 97 plus x equals 180. Subtract 97 from both sides. X should give you 83. Okay? That's one way of doing it. The other way is noticing that since this should equal this plus this, we could just do this. X plus 35 equals 118. I would suggest finding y the same way because it's just as easy to do so. But otherwise, you have 118 here. You have x plus 35 here. If you subtract 35 from both sides, you'll still get x equals 83. Both ways work, either doing it this way or this way, but find y by how I suggested. Whether or not you find x, either way, it's up to you. Either way, to me, is really easier. So, next one. Okay, once again, we're going to find y. We know these two add up to 180, so 67 plus y equals 180. All right, so we subtract 67 from both sides. We get y equals 113. Then we can do the same for x. We get, how I taught my kids is we take the y, which is 113, we add the 45, we add the x, we set it equal to 180. This combines together to give us 158 plus x equals 180. Subtract 158 from both sides. You should get x equals 22. Okay. Here's a little bit tougher ones. These down here. Finding y is the same way. We still take 125 plus y equals 180. Still subtract 125 from both sides. We get y equals 55. The only difference is that instead of having one x and one angle, we just have two x's here. So as I said, if we take this plus this plus this, we should be able to make it 180. Now if you want to do it like we did earlier right here, you're just going to take this plus this and set it equal to 125. Or if you want to do it my way, take this plus the y we just found, 55, and set it equal to 180. So we got our y, which is 55, plus our first angle, which is x plus 3, plus our other angle, which is x minus 10, and we set it equal to 180. Let's combine our x's. We've got 2 x's, so we've got 2x. We got 55 plus 3, which is 58, minus 10, which is 48. Set it equal to 180. Subtract 48, subtract 48. 2x should give you 132. Divide by 2, x equals 66. So y is 55, x is 66. Second one, same idea. 37 plus y equals 180. Subtract 37 from both sides. Y should give you 143. Alright, so we're going to take the y plus the other x's. So we're going to take 143. We're going to add the first angle, which is x minus 12. So add the second angle, which is 3x minus 3. So that equal to 180. Then we're going to combine like terms. We have 1x here, 3x is here, so we got 4x. 143 minus 12 is 131. Minus 3 is 128, so we add 128. Set it equal to 180. Subtract 128. Subtract 128. 4x should give you 52. Divide by 4, divide by 4. X should give you 13. So here, y is 143. X should be 13. Alright. Next part, kind of its slope. Alright. So, the easy way to remember this is like this. Your slope's going to be positive if you think of a man going from left to right. Alright, if he's going from left to right and he's going up, it's positive. If he's going from left to right and he's going down, it's going to be negative. So this first one, it's positive because it's going up. If I start here, the furthest left point, I can count how much I rise over how much I run. I rise 1, 2, 3. So I went up 3. So then I'm going to start my slope by going up 3. Then from there I go over 1, 2, 3, 4, 5, 6. Go over 6. So I rose 3, went over 6. If I reduce this by dividing by 3, I would get my slope is 1/2. The other one, I rise 1, 2, 3, 4, 5. I go over 1, 2. So I rose 5, 1 over 2. Can't reduce that, so your slope is 5/2. This one down here. Now, from left to right, it's going down, so this is going to be a negative slope. So I'm going to put my little negative there to start with. I go down 1, 2, 3, 4, 5, 6. Went down 6, go over 1, 2, 3, 4. So it's -6/4. If I divide both by 2, I should get -3/2. Last but not least, once again, we're going down. So down 1, 2. So -2. To the right, 1, 2, 3, 4, 5, 6, 7. -2/7. Alright, that's how you find slope from a graph. Now you guys technically could use these 2 points right here. I just feel like actually counting is a lot easier than doing the slope formula. Speaking of slope formula, we're going to use it down here. So once again, we're using y2 minus y1 over x2 minus x1. y2 minus y1, x2 over x1. This is your x1, this is your y1, x2, y2. Alright, remember x is always the first numbers, y is always the second numbers. Okay, so we're going to take the y2, as it tells us, which is 7. We're going to subtract y1, which is -4. Now notice I put that negative sign there before I put the -4 there. The reason is you have to do that so that when it comes to this point where we see that we have 2 negatives, we know we should add. So technically we're going to add here and make 11. This is all going to be over 5 minus 3, which should give us 2. So our final product is 11/2. Alright, I'm going to switch to a marker because my pencil's running out of sharp end. Next step, find the slope of the line. So, once again, we've got x1, y1, x2, y2. So we're going to take 9 minus the -2 over -3 minus 8, which should give us 11 over -11, which should give us -1. I'm going to reduce it because these should be plus plus. Alright, we just got one more page to go. So we're using the x1, y1 thing again. x1, y1, x2, y2. So you're going to take 7, subtract a -5. All over 4 minus -3. So these should become plus plus, these should be plus plus, so that's 12/7. Alright, now graphing lines. These might look complicated, but they become a lot easier once you realize what these numbers mean. So this thing is our slope. Remember, this is our rise over run. This thing is our y-intercept. This is where we begin. So what it's telling us is we need to begin at -3, meaning we had to find -3 on this y-axis. Let me put a little point there. Okay? Because this is the point where the line crosses the y-axis at. It's called the y-intercept. We're going to put a little point there. Then we're going to take our slope, which is 3/4, and we're going to get first to the rise, which is up 1, 2, 3, and then our run, which is over 1, 2, 3, 4, and put our second point. We can connect the dots, and there you go. This other one, okay, that's a little bit tricky because we don't have a run. Now, whenever we don't actually have a fraction, we turn it into a fraction. 2/1 is the same thing as saying 2, because 2 divided by 1 is still 2, but at least now we have our run. So once again, we look for y-intercept, which is 4. We're going to pull a dot there. We're going to do our rise over run, which is rise 1, 2 over 1. Combine like, not combine like terms, draw through your 2 points. There you go. This next one's a little bit tougher because it doesn't look like the previous ones. So this is called point slope form. We're going to learn how to turn it from point slope form to what's known as slope intercept form. So first step, you're going to take this 1/3 and you're going to multiply both things on the inside. It's called distributive property. Alright, don't forget stuff from algebra. So when we do that, we still have y minus 2, but now 1/3 times x is still 1/3 x. 1/3 times -3, if you put in your calculator 1 divided by 3, you'll get 0.3 repeating, multiply by -3, you should get -1. Next we need to get rid of this 2, so we add 2 to both sides. So we get y equals 1/3 x plus 1. Now we have our y-intercept, we have our slope, so we can put our dot at our y-intercept, which is 1, and then we got our rise over run, 1, 2, 3. Connect our dots. We got ourselves a line. Next one. Same thing. We're going to distribute this through. And get y plus 3 equals 3/4 x. When you multiply these out, you should get 6. Subtract 3, subtract 3. Y should give you 3/4 x plus 3. Okay, so we know our slope is 3/4. We know our y-intercept is 3. So we're going to put a little dot here. We're going to rise 1, 2, 3. We're going to go over 1, 2, 3, 4. We're going to connect our dots. Be done with it. Okay, we're going to do the same thing again. Distribute. You get y minus 4 equals -2x. Remember, negative and negative makes positive, so plus 4. We're going to add 4 to both sides. So that gives us y equals -2x plus 8. Remember, we had to put the 1 to that for the rise over run. We find where 8's at, put a dot. Now, this is a negative rise. That means we have to go down that much instead of going up that much. So we go down 1, 2, and we go over 1. There's our line. All right, once again, the last one's just like what we've been doing before. Y-intercept is 3, so we find where 3's at, put a dot. We know our slope is -2/3, so we go down 1, 2, over 1, 2, 3. The second dot, connect our dots, and there you go. Alright. Last but not least, the final page. Alright, so something important you need to remember. When y equals a number, it makes a horizontal line. So think of it this way. When you have y equals, make sure the line goes through the y-axis. When you have x equals, right? X equals just one number. There's no other variables. X equals a number is vertical. Once again, you can think of it as if it's x equals, it has to go through the x-axis. So first, we're going to see where y equals -2. So we found -2 on the y-axis. And we have to make a horizontal line there. So we're going to make a horizontal line right here. Okay. X equals -6. We found where -6 is. We're going to make a vertical line. Notice how these lines are passing through the axes of the equation. X equals -6 goes to the x-axis. Y equals -2 goes to the y-axis. Next one. Y equals 3. So we're going to find 3 for y. Make a horizontal. We're going to find x equals 5. So we're going to make a vertical. Last one. X equals -5. So we find where x is -5 at, which is right here. Make a vertical. Y equals -2, so we're going to find where y equals 2 at and make a horizontal. Should look like that. Okay. So, next thing, explaining what perpendicular, parallel, and lines are. Now remember, perpendicular slopes, what they have are opposite reciprocal slopes. That means that they are opposite, meaning different signs, and reciprocals, meaning the fractions are flipped. Parallel has the same slope, so it has to be the same number for it to work. Neither means that it's neither or. Okay, so we're going to do this first one. So, line 1. We're going to use the slope formula again, which is y2 minus y1 over x2 minus x1. We're going to solve like this. We're going to take y2, which is negative 2. We're going to subtract y1, which is 5. Put it all over x2, which is 9, minus x1, which is 4. You should get negative 7 over 5. So the same thing with the second one, 0 minus 7 over 2 minus a negative 3. 0 minus 7 is negative 7. 2 minus negative 3 means 2 plus 3, because there's 2 negatives, it becomes positive. Now we have negative 7 over 5 and negative 7 over 5. So, because they're the same exact slope, we can call these parallel. Next one, right here, we're going to do the same thing. We're going to take 2 minus 5, put it all over 7 minus 3. You should get negative 3 over 4. This one, we take 6 minus 3, put it over 8 minus 7. We get 3 over 1. 3 over 4, 3 over 1, they have nothing in common, so they are neither. Okay, this one, we're going to take 9 minus 4, all over 6 minus negative 2. You should get 5 over 8, because negative, negative becomes positive. Next one, which is negative 5 minus 3, all over 10 minus 5, should give you negative 8 over 5. Now, notice how these are flipped. One's positive, one's negative, so we can call these perpendicular. Okay, so those are perpendicular. Okay, next one. So we're going to take this, 8. We're going to subtract the 6. 4 minus 5 should give you 2 over negative 1. This one, you can take your 8 minus 7 over 12 minus 10, which should give you 1 over 2. So these are flipped. One's positive, one's negative. Perpendicular. This one over here, 2 minus 7 over 5 minus 9 should give you negative 5 over negative 4, or what it should equal, which is 5 over 4, since there's 2 negatives. Whoop, my bad. This other one should be negative 7 minus a negative 2, all over 0 minus 4. Plus plus becomes negative 5, negative 4, which also equals 5 over 4. So they're both the same slope, parallel. Alright, last but not least, we're going to look at these. Now remember, perpendicular they do cross each other, but they meet at a right angle. Now there's one way to tell whether or not these are perpendicular. And that is doing pretty much what we did in the previous page, which is actually finding the slopes themselves. So if we start on A and we go down to its second point, which is B, we can figure out the two different types of slopes we've got here. So let's look at this one. So we go down 1, 2, 3, 4, 5. So we went down 5, so that's minus 5. If we went down 5, we went over 1, 2. So we went 5 over 2. So we can see that is, see we have that slope for that one. So that's line 1. Line 2, okay, we go up 1, 2, 3. So far so good. We know that we need a positive, we need a negative. We do have a negative, we have a positive, and we go over 1, 2, 3, 4, 5, 6, which equals 1/2. Alright, since negative 5 over 2 and 1/2 are not opposite reciprocals, and they are not, they're not the same number, we know these aren't perpendicular, okay? So not perpendicular, they don't have opposite reciprocals. Last but not least, parallel. So once again, let's do the same thing. Let's figure out what they are. We can figure out if they're parallel from there. So line 1. Go up 1, 2, 3, 4. Go over 1, 2. 4 over 2 or 2. Line 2 is 1, 2, 3, 4, 5, 6, 7, 8, 9. We go up 9. We go over 1, 2, 3, 4. Okay. So these aren't the same, so it doesn't work. So they're not parallel because they're not the same slope. Alright, thanks for watching.